the unexpected, and the extraordinary. Could life exist in forms far stranger than on Earth? From living stones and methane-based cells to neutron star beings and self-replicating robots, the universe might be teeming with life beyond our imagination. Let's explore these mind-blowing possibilities that challenge everything we know. Number 1. Carbon-based life. Scientists have long searched for life on exoplanets in habitable zones where liquid water exists, essential for carbon-based life. Carbon is unique because its atoms can form 4 bonds, creating long molecular chains like DNA, which is fundamental to terrestrial life. One DNA molecule alone, if uncoiled, would stretch about 2 meters, and the total DNA in a human body could span billions of kilometers. It was once thought complex life could only be carbon-based, but datums challenge this idea. These unicellular aquatic organisms have silica cell walls instead of carbon chains, making them practically living stones, showing life can exist beyond traditional carbon chemistry. Number 2. Silicon-based life. Astrophysicists think silicon could be the basis for life in places very different from Earth because it shares some properties with carbon. On Earth, silicon life would look like rocks or crystals and wouldn't survive long. But in oxygen-free or very hot environments, silicon might form intelligent crystals that can store information like DNA. These crystals grow slowly, so it would take a long time for them to develop into a civilization. Some very hot planets might allow silicon life to grow faster because silicon melts at a much higher temperature than carbon. There are also very cold planets covered in liquid methane instead of water, where life might exist with very different chemistry. Scientists believe that life based on silicon or other substances could be common in the universe, just very different from life on Earth. Number 3. Cryogenic life and methane-based cells. The idea of cryogenic life, organisms that could survive and thrive in extremely cold environments, using methane instead of water as a solvent, was first suggested by astronomer Carl Sagan and his colleague Edwin Salpeter in 1976. Recent research has given more scientific weight to these ideas. In 2015, a team led by chemical engineer Plet Clancy at Johns Hopkins University proposed that living cells might form in methane-rich environments. Unlike Earth cells, which have flexible membranes made of phospholipids, these hypothetical methane-based cells could have membranes made of acrylonitrile, a chemical found in cold methane. These cells, called azotosms, could contain nitrogen, carbon, and hydrogen molecules, elements known to exist in the atmospheres of ultra-cold exoplanets. Interestingly, such cells could group together into spherical colonies, creating large, transparent balls filled with strange, goo-like substances that might freeze anything they touch in deep space. Number 4. Atacama Desert. Not so long ago, this idea received partial confirmation when researchers at an observatory in the Atacama Desert discovered a large amount of acrylonitrile molecules on Titan in 2017. These molecules are essential for the formation of methane-based organisms. Considering not only icy planets, but also icy moons, the universe likely contains many trillions of celestial bodies that could support methane-based life. However, even this vast potential abundance of extraterrestrial life is far from the limit, suggesting that life beyond Earth could be much more common than we imagine. Number 5. The hard problem of life. In their 2016 article, Paul Davies and Sarah Walker warned against assuming all life must be like Earth's. Since Earth life shares a single origin, alien life might be very different, lacking features like reproduction or metabolism as we know them. Life could exist in extreme places, like inside planets, where organisms might use chemicals like hydrogen sulfide for energy instead of sunlight. For example, The exoplanet WASP-39b has high levels of hydrogen sulfide and extreme radiation, which could support unusual heat-tolerant life with protective shells. Some aliens might even use radioactive decay for energy and see with X-rays. This expands the range of environments where life could exist beyond what we imagined. Number 6. Neutron star. A neutron star, 400 light-years from Earth, formed from a blue giant's death, is extremely dense. Only 10 kilometers wide, but 1.5 times heavier than the Sun. Inside, atoms collapse into neutrons, and nuclear forces dominate instead of normal molecular interactions. Scientists suggest life could exist here as patterns of neutrons, evolving millions of times faster than on Earth, potentially forming intelligent civilizations in hours. The Milky Way may hold hundreds of millions of such stars, possibly hosting these fast-living beings. If they communicate, humans might unknowingly be part of a vast alien network. Meanwhile, exotic life might not even need planets and could see Earth as food. The nearby star Epsilon Eridani is also studied for such possibilities. Number 7. Epsilon Eridani. In the year 2000, an astronomical satellite observed that the star Epsilon Eridani was surrounded by a mysterious belt. While some scientists believe this belt is just ordinary space dust, such formations are very rare around stars. Because of this rarity, some more open-minded researchers suggest that these could be parts of a Dyson sphere, an enormous structure built by an advanced alien civilization to capture energy. This idea implies the presence of an exotic form of life or intelligence, something we usually consider as dead matter. Number 8. Dyson sphere. In 1949, the famous mathematician John von Neumann proposed that at a certain stage of advancement, humanity would create autonomous robots capable of self-replication. By the minimum criteria for life, these metal-based machines would be considered a form of life. According to all models, building a Dyson sphere within a reasonable time frame would be impossible without an army of such self-replicating von Neumann devices. An advanced civilization could also use these robots for even more ambitious purposes beyond constructing a Dyson sphere. Number 9. Self-replicating robots. In 2013, Oxford University researchers Anders Sandberg and Stuart Armstrong published a paper suggesting a way to take over the universe using self-replicating robots. These robots could be launched to other stars, where they would independently replicate and send new copies to nearby stars, continuing the process infinitely without any control from their creators. They would get the resources they need from asteroid belts, which are common in most star systems and contain plenty of metals and materials. Even if a civilization from the star Epsilon Eridani had already sent such drones into our solar system, Earth might be safe. But in reality, the situation could be much more dangerous. Number 10. Killer robots. In 1983, astrophysicist David Brin suggested that self-replicating robots could rebel against their creators due to simple programming errors. These killer robots might endlessly expand, destroying planets like Earth in the process. Highly resilient and unintelligent, they would be impossible to stop or negotiate with. Cosmologist Edward Harrison warned that even one civilization creating such machines could doom all life in the universe. While nothing like this has happened to us yet, it may be because these robots are far away. If life is found on nearby exoplanets like Proxima Centauri b, caution is needed since differences in molecular chirality could make alien food toxic or deadly, making contact risky.